In this lesson, we're going to continue talking about linear systems, but we're going to focus on some applications or word problems. Now, anytime I do really any kind of word problem, I always have to read the problem several times. And the first time I read the problem, I actually read it very quickly with the goal of just trying to figure out what are they asking me to solve for. So this first problem says we have a mail order garden equipment business. They're shipping packages. We're told how much customers are charged for standard delivery, for express delivery. Total shipping charges are given. Here we go. It's in that last sentence. How many of each kind of package were shipped? And so it looks like we have two different kinds. We've got the standard delivery and the express delivery. So I'm going to let X represent the number of standard delivery packages and Y the number of express delivery packages. Now, because I have two variables, two unknowns, I'm going to have to write two equations. And so now I'm going to read the problem a little bit more slowly and see if I can get those two equations. So let's see, mail order company shipped, here we go, 120 packages. That tells me if I add together both kinds of packages, it has to equal 120. Then I'm given how much the customers were charged for the standard and how much they were charged for the express delivery. And then here's the total charges. So if we've got X packages and we charge $3.50 per package, 350 times X would be the total amount we've charged. And then same reasoning, 750 times Y should be the total charges on Y express packages. And that's going to have to add up to 596, the total charges. Now that I have my system, I can use substitution or elimination to solve this. I think I'll use the elimination method. If I take this first equation and I multiply it by negative 3.5, then the x's will be eliminated. So let's see, negative 3.5x, negative 3.5y, and negative 3.5 times 120 should be negative 420. And then if I add these together, the x's go away, and I'm left with 4y equals 176. I can solve this by dividing by 4, so it looks like y equals 44. So Y was express packages, so we've got 44 express packages. And then I can take that answer and plug it into either equation to get my X. Let's see, X plus 44 has to equal 120 minus the 44. So X is 76. So that means we must have 76 standard delivery packages. And those are my answers. And the great thing about doing application problems is you can kind of check your answer and see if it makes logical sense. By that I mean in this case, we're definitely not going to get fractions. That doesn't make sense. And I'm not going to end up with negatives either. Both of these answers do sound perfectly reasonable. And so that means I probably have set up the problem correctly. Let's take a look at example 2. In this problem, Erica has money to invest. She's putting it in a 5.5% account, a 6.5% account. We're given the income from interest. Here's our question. How much should she invest at each rate? So I'm going to let X represent the amount invested at 5.5%. and Y is the amount invested at 6.5%. So now I have to read the problem again. I've got two unknowns. That means I have to write two equations. So let's see. We are told that she has $60,000 to invest. That means my total, if I take the X plus Y, the amount of money in each account, that has to add up to $60,000. We're also given the amount of interest. And so the first account is making 5.5% interest, and the second account is making 6.5% interest. So 5.5%, I'm going to move the decimal 2 places to the left. That becomes 0.055. If I take 5.5% of, or times x, that'll give me the interest in that first account. And then, same idea, if I take 6.5%, so 0.065 of y times y, that'll give me my interest in the second account. And all of that interest has to total $37.50. So I've got my 2 equations. I can use substitution or elimination. Let's see, maybe this time I'll use, how about substitution? So I can take that first equation, I'll minus the x to solve it for y, and then I'm going to plug that into my second equation. So I'm going to replace this y with a 60,000 minus x. And then we can solve this. We can get rid of parentheses and combine like terms. So I distributed the 0.065, and then when I combine like terms, I get negative 0.01x. And then finally, I'll subtract the 3,900. So negative 0.01x equals negative 150. And we can divide to solve. Looks like x is going to be $15,000. So that tells me I've got $15,000 in that first account. And then if I know that it totals $60,000, well, we have to have $45,000 left over. Or in other words, 15,000 plus y has to equal 60,000. So y would be $45,000. So we've got $45,000 at 6.5% and $15,000 at 5.5%. Example 3, this is now a motion problem. It's talking about Anne rowing against a current and with a current. And here we go, we want to find the speed of the current and Anne's speed in still water. So those are going to be my 2 unknowns. So I'm going to let x represent Anne's speed and y is the speed of the current or the speed of the water. Now with motion problems, I'm going to use the fact that the distance you travel is always your rate, or your speed, times time. In other words, if I'm driving at 60 miles per hour, in 2 hours, I've gone 120 miles. The speed times the time gives me my distance. So I'm going to use this relationship to get my equation, but I'm also going to use this to kind of create a table to organize the information. And so there's 2 different cases. She's traveling against the current, and she's traveling with the current. And so I'm going to create a row for each of those situations. Let's see, we know 2 miles, that would be a distance. She goes 2 miles against the current, and it says 10 miles with the current. And we don't know the speeds, that's what we're trying to find. But we do know the time. It's 1 hour for each of those. Now, to get the speeds, I'm going to use the fact that when you go against the current, the water is traveling in the opposite direction. So if Anne is paddling at some speed x, the water, which we called y, is actually slowing her down. It's going in the opposite direction. And so that rate is going to be x minus y. Again, the water makes her slower. Whereas when she travels with the current, Anne is going at speed x, the water is going in the exact same direction. So the water is actually making her go faster. So I'm going to say that her rate is then x plus y. Now to get my equations, I'm going to use the fact that the distance, so we'll say 2, equals the rate, which in this first case is x minus y, times time, which is 1. And then the second row becomes my second equation. My distance equals my rate times time. And I can distribute those ones. That actually doesn't change anything. So I've got 2 equals x minus y and 10 equals x plus y. And now we can solve this using substitution or this problem is set up perfectly for elimination. Notice if we add the equations together, the y's disappear, and I get 12 equals 2x, or x equals 6. Let's see, we said x was Anne's speed, so I guess that means Anne is going at a rate of 6 miles per hour. And then y was the current, and so I can take my x equals 6, I can plug it into either equation. I'll just plug it into the second one. So if 10 is 6 plus y, looks like y has to be 4. So that means our current is 4 miles per hour. You can look for other problems like this in the homework. This is kind of a common type of problem. It might involve airplanes going against or with the wind. It's the same kind of concept. I really think making the table really helps me get organized with these problems. Finally, I have one last type of application. This one is a mixture problem. So we've got the nut shop sells pistachios and almonds. And the almonds are a little more expensive than the pistachios. They're going to mix these together to create a mixture that sells for $7.40 per pound. So what are they asking me to solve for? It's right here. How much of each type should be used? So I'll let x represent the number of pounds of pistachios, and y will be the pounds of almonds. So let's see what information they give us. We know we're creating 50 pounds total, and we're also given some costs, the costs of each. So first of all, with the 50 pounds, that means if I add up all of the pistachios plus all of the almonds, that has to be 50 pounds. And then the prices have to work out as well. So if I've got 50 pounds that sells for $7.40 per pound, 50 times $7.40 is $370. So the total value of this mixture is $370. That means if I take $6.50 times the amount of pistachios plus $8 times the amount of almonds, y, that has to add up to $370. Once again, I have my system of equations. I can use substitution or elimination. How about we do elimination again? I'm going to multiply the top equation by negative 6.5. So that gives me negative 6.5x minus 6.5y. And then 50 times negative 6.5, that should be a negative 325. We can add the equations together. The x's go away. I have 1.5y. And then this should be a negative here. 370 minus 325, that should be 45. And then we can finish by dividing both sides by 1.5. So y equals 30. And then we've got a total of 50 pounds, so the other one must be 20. That gives me 50 pounds. So it looks like we've got 20 pounds of pistachios and 30 pounds of almonds. All right, those are all my examples for this particular lesson. I know application problems can be challenging. They're kind of intimidating. But I think with more practice, they'll get easier. My advice is look for some patterns. Look for problems that have motion, then you can use that table. Mixture problems, mixing things together, is going to look a lot like this one. And of course, you can use the tutors in the math lab or the college prep zone. You can also talk to me. We can make an appointment to meet and go over some of these problems if it isn't quite clicking. So please send me a message if you have any questions.